You're trying to find the integral value from -1 to 1 of sine x over x dx by using Taylor series, and precisely n is equal to 3, right? So 3 non-zero terms of Taylor series. Okay, so now in order to find this, we first have to find the Taylor series for sine x over x, right? So we know that we can use sine x, and we're interested to find Maclaurin series, right? Because 0 happens to be right between -1 and 1, so we're interested to find the Maclaurin series for sine x, right? So that's going to be from k is equal to 0 to infinity of -1 to the k divided by 2k plus 1 factorial times x to the 2k plus 1, right? And this is true for negative infinity for all x values, right? Negative infinity is less than x is less than infinity. So now sine x divided by x, well, first, before we do that, we have to find sine x divided by x. So all we do in this case is going to be what? Is going to be taking this. So we will have this, and we will divide by x, right? So dividing this by x essentially removes the plus 1, right? Because we will have plus 1 minus 1, right? Using the properties of exponents, you will subtract 1 here on the top because you're dividing by x, right? So you're removing the plus 1. So it's essentially x to the power of 2k. That's it. And also same thing, right? True for all x values. Okay, so this expansion is going to be what? It's going to be 1 divided by 1 factorial, right? Because when k is equal to 0, everything will be 1. X to the 0 is 1, -1 to the 0 is 1. This thing, when k is equal to 0, will be 1 factorial, right? So then you will have an alternating sign, right? Because when k is equal to 1, there's a negative number. So you will have minus x squared, right? When k is equal to 1, minus x squared over 3 factorial now, right? Because k is equal to 1, right? 2 plus 1 is 3, right? And then plus, right? We keep alternating signs because of that -1. And k increase dictates the change all the time, right? Then we would have x to the 4th, right? Because k is equal to 2, so it's x to the 4th. And then divided by 5 factorial now, right? Because k is equal to 2. 2 times 2 is 4 plus 1, 5, right? And etc., minus, and then it just keeps changing signs and increasing powers of x, and so is the denominator. It increases by 2 all the time for the factorials, right? So then sine of x. Now, why did we stop there? I stopped there because we need to find only 3 non-zero terms of this Taylor series, right? We already found this is non-zero, this is non-zero, and this is non-zero, right? So sine x divided by x is about 1, right? Minus x squared over 3 factorial is 6, right? Plus x to the 4th over, what's 5 factorial? 24 times 5 is 120, right? So that's 5, right? So we found the approximate value of sine x over x, which is 1 minus x squared over 6 plus x to the 4th divided by 120, right? So this integral, sine x over x dx happens to be transformed into, the integrand becomes 1 minus x squared over 6 plus x to the 4th over 120 dx. Okay, so what would we have? We would have basically x for the first antiderivative here, right? X from -1 to 1 is basically 1 minus -1, right? That should be simple. And then minus, the minus sign is there, the power increases by 1 and also multiplies the denominator, so 1 over 18, right? And x to the 3rd, right? X to the third. So you will have basically 1 to the third minus negative 1 to the third, which is the same as 1 minus negative 1 as before, right? Just like this one. And then plus, right, 1 over 120 will be multiplied by 5 because the power of 5 will also be the denominator. Okay? So 5 times 120 is 600, right? Plus 1 over 600, x to the fifth. And again, since the power is odd, it's 5, just like it was 3 here for the antiderivative and the first power, it will be basically 1 minus negative 1, right? 1 to the fifth minus negative 1 to the fifth is the same as 1 minus negative 1. Okay, so then what would we have? We would have 2. This is 2. Then this is 2 divided by 18, which is 1 over 9, right? So minus 1 over 9 plus 2 over 600. 2 over 600 is 1 over 300, right? Simplified. Now we know that the greatest common, least common multiple is 900 for these three, right? 900 times 2 is 1800 minus, and this will be multiplied by, to get 900 in the denominator, you will need to multiply it by 100, right? So minus 100 plus, and this will be multiplied by 3 in order to yield 900, so 3, and the whole thing divided by least common multiple, or least common denominator in this case, right? So that's going to be what? That's going to be 1703 over 900, which is equal to what? This is equal to about, if you use your calculator, 1.892. Now this is really cool because the actual integral value is also 1.892, right? So this happens to be a very straightforward integral because we're getting exactly the same result. Usually it's very close, but this is exactly the same, rounded to 3 decimal places. I'm going to show you in the next examples that we would have an approximate value, but not exactly the same answer. See you in the next video. Thank you.